Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Evergreen Elementary School, home of the Eagles, and today we're all here to do the math! Back here at Evergreen Elementary School, home of the Eagles, I'd like to introduce you with our working team today. We got about 20 fifth graders here at Evergreen. Say hey, everybody. Hey! I thought I was going to have one person say everybody at the end because it's literally what I asked them to do. So I love that we got this very warm and playful room here. Everybody's really well spaced out. Let me have everybody kind of come in here. I feel like I'm going to go back to kindergarten. Look at this kind of rug with letters on it. I'm going to go ahead and have a seat. Why don't you guys come on down with me here? I don't get to do this often, and I don't know if my insurance is going to cover this if I try to get back up too quickly. So thank you for joining us here on the carpet. This is like kindergarten again, huh? Do you guys like kindergarten? Yeah. Everybody loves kindergarten except one lady over here. So here's what I want to talk about today with our fifth graders as we kind of turn back the clock. I want us to join together for an activity that I call Same or Different. So what you're going to see on the board here are going to be two images that are mathematically related. They could be expressions, they could be an algorithm, they could be conceptual models, they could be visual or image, could be anything. And what I want you to do with your groups, because they've already set up, you guys are in groups of 5. After these visuals go up and you take about 15 or 20 seconds to think to yourself about what you see, go back to your group and I'm going to have you answer a very specific question. Are we ready? Yes. I know you guys just got comfortable on the carpet and now I'm making you go back, but we're going to wait here for a second, okay? We'll hang out here, take a look at the board, and observe these two visuals. Take about 15 or 20 seconds to look at these two. I wish you guys could see what I would see. All these gears turning, the wheels spinning. What I would like you to do back at your groups is discuss with your teams what is the same about both of these. Are you ready? Stand up, back to your groups, go! So right now our teams are looking at both of these figures. And if you have been exploring multiplication in depth, especially at the 5th grade level, even as far back as 4th or 3rd grade, you might recognize this figure here as an area model. Now an area model is very helpful with multiplication because it allows us to break down pieces of multiplication. You may also be familiar with this. Now, we didn't reveal what operation this involves, but you could possibly guess. However, we did not include the product of these, just the pieces. And I'm really curious to see exactly who puts together the idea that these both represent the same product and the same sums. So, let's figure out what everybody had to say here.
And 40 times 30 equals 120, and 40 times 40 equals, I forgot.
Now, somebody over here said something really interesting. You guys can keep going. You don't have to wait up for us. There's a lot that you can notice, so keep that conversation moving. Somebody over here noticed that there are some similar values across the way. I believe it was you that said something about 170?
Yes.
What did you notice about 170 appearing?
170? Well, I just multiplied it in my head, and like, I see the number down there, 1360.
Okay.
Yeah, and I just see it. I'm just like, the only way you can get that number is by multiplying.
Okay, so you recognize that both of these are multiplication related.
Yes.
Okay? Now you mentioned 170, and that's one of the numbers that appears on the left side. Do you see 170 appearing anywhere on the right side?
I do not.
Okay, let's see here that we wouldn't see 170, right? Well, so let me ask this then. How, if this was multiplication on the left, how would we get 170? So what's interesting is that we recognize this as multiplication, but how that works and why it's multiplication we can have a conversation on. So what else did we notice that was the same between these two? Let's start off and visit each group very quickly. Go.
That one's multiplication.
They both deal with multiplication. Okay, there's a lot of inference. What tells you that they both deal with multiplication?
Because that one is standard algorithm.
Okay, we have a standard algorithm for multiplication on the left side. What about the right side? Does anybody recognize that right side as anything related to multiplication? Right back here. What do you call that again?
Area
So
model.
this is an area model, okay? So they both deal with multiplication, but they're different in that this is a standard algorithm and this is an area model. Is there one more thing that you recognize about both of these out of the same? Let's go to this group over here. One more thing that's the same about these two.
They both use the same numbers?
They both use the same values. Which numbers are the same in both of them?
40 and 30.
So
45
you see
and
a
30.
40 and a 30 here. Do you see 40 and 30 appear within here in any form? Because you're right, there is a 40 here and a 30 here. And when we come back, we're going to dive deeper into the similarities between these two models. Back here at Evergreen Elementary, we have continued the conversation, and I think the conversation has stopped since they knew that we came back here. But while you were gone, some really interesting connections about similarities between the two figures that we'd explored with our same different prompts. So we're going to revisit that and then get into the different parts. So let's take a look and see what we've built up here. Welcome back, everybody. So I want to share with our audience at home some of the similarities that you identified with our same or different prompt here regarding these two representations of multiplication. So I want to share some of the things that the groups came up with. We had a group identify that both end up with the same product, and that was a good reasoning sense. The idea that if you're multiplying two numbers together, it doesn't matter how you do it or in what order, you have to have the same product. Also, that both involved using addition. And I thought that was very insightful, that both involve you adding some numbers together to end up with that product. We had one group identify something unique about the set of factors involved that appeared in both, the fact that both use one odd factor, 45, and one even factor, 34. And that makes sense because, again, we both have the same factors being used in both figures. And then we had an interesting observation that both involve adding 170 and 1360, or 1,360. And so that might not be immediately apparent in the area model, but if you look at what happens when you multiply 30 and 4, oh, I gotta go back here. When you multiply 30 and 4 with, oh, there we go, with, thank you very much for calling me this out, breaking through the fourth wall here. The mysteries of television have been shattered, ladies and gentlemen. But when we multiply 30 and 4 times 5, we end up with 30 times 5, which is 150, plus 4 times 5, which is 20, and when we add these together, we get 170. So, logic would state that we could do the same thing up here with these two and end up getting 1,360, and that works. As we left for break, we started a conversation, and it's been going on for about 5 minutes or so. Now that we've identified what is the same, we want to discuss what is different. And obviously the first thing they identified that was different is the fact that one is a standard algorithm and another is the area model. But I was curious. I wanted to see what else is different. So let's go back to our groups and see what they have to offer. Let's start where we ended last time. We'll go here, okay? What was something you identified as a difference between those two figures?
They're both a different way. They're both solved a different way.
So they're both solved a different way. Could you kind of explain a little bit more on what you mean by that?
I mean, like, you're trying to find the problem of algorithm.
So let me ask you how you would start with the standard algorithm. What would be the first step in solving 34 times 45 in the standard algorithm?
Starting from the right and
Okay, so it sounds like you're starting off by multiplying 4 times 5. That's your first step. What would be your first step in the area model?
by multiplying each cube.
So what I'm hearing is it doesn't matter which two numbers you multiply first in the area model, but the standard algorithm almost forces you to multiply the ones places together. Whereas in the area model, you can start wherever you want. So that's a really interesting connection. We'll get that up there in a moment. Let's visit our group in the back. What is different about these two figures?
Something we said is that in the standard algorithm, it has 34 and 45 just together, but in the area model, it separates the 34 and the 45 by tens and ones.
So what you recognize is that the area model breaks apart your factors by place value. But the standard algorithm doesn't. It brings that value together as a whole. So that's an interesting connection. Let's go to our gentleman back here. What is a difference that you've identified?
The area model is less, and then the standard algorithm is higher.
So what do you explain what you mean by that? Less or higher? Can we be more precise in what we mean by that?
Well, the area model has the less numbers.
Okay. So what I hear you saying is that the numbers we end up adding together in the area model end up being smaller than the numbers that we end up adding together in the standard algorithm. That's a really interesting look at that, and it's the reason why so many people love the area model. One more very quickly, one more difference here.
This one has it shows the answers, but this one doesn't. You have to add this one up, and you have to put it the 34 and 45, and you have to multiply that.
So what I'm hearing you say is that most of the numbers have already been combined here, whereas you have to do a little bit more work to add some more numbers together on this one. So what this ended up becoming was a conversation about the pros and cons, the pluses and the minuses of standard algorithm versus the area model. So when we come back, we're going to bring it all together with a new way to make sense of multiplication. Back here at Evergreen Elementary, wrapping things up today for another episode of Do the Math. And when we left, we started talking about the differences between those two representations of multiplication, the standard algorithm and the area model. And as we left, there was a conversation about which one we prefer. And it became a really rich discussion about the benefits and disadvantages of both of them. And so I dropped a mental rock on these kids when we were in the break. And the question I asked was, both are all right when working with whole numbers. But what happens when we throw a fraction into the mix? And I had that conversation and let the groups really brainstorm together about what would happen if you have to multiply a mixed number, that is a value that has both a whole number and a fraction, and you multiply that times a whole number. So I'm going to go ahead and throw out an example. I'm going to put an example, I'm going to create one on the board. And let's have a conversation on how we might solve that. Is everybody ready? So as I'm putting this on the board, why don't we come back around onto the carpet for one more time today. We're going to do 5 1/2 times 11. 5 1/2 times 11. Now, what did we talk about as far as ways we can multiply a whole number versus a mixed number? What were some of your ideas that you brought from your groups? What were some of the things you discussed? We got kind of stuck. There was a lot of great conversation. Let's start off over here.
That if you add like one more, it will become 6 wholes.
Oh, so if we had 6, that'd be easier to multiply, right? But we don't.
Yeah.
That happens never come to rescue us, although I want to hold on to that idea. How many people were thinking about the standard algorithm, what that would look like? Could we really do standard algorithm with 5 1/2 times 11? It'd be really tricky, right? So let's think about the area model. Could we try this with the area model? What would that look like? What would I have to set up for an area model? How would I draw that? Yeah.
We're drawing a box?
Let's do a box first, okay? So we're going to create a rectangle that we can now split up. Now we have our 2 factors. How could we split up those factors? Yeah. By 3. What do you mean by 3? Well, remember, like both of these ended up being the sum of these values, right?
By splitting them up.
So how could we, let's start off by, which one do you want to split up first? 11, right? How can we split up 11?
By just 10 and just take away the
10 and
1.
1, you're absolutely, that sounds great to me. Let's do that. Let's do 10 and 1. Because 11 is just 10 plus 1. What about 5 1/2? How could we split that up? How could we split up 5 1/2? What are your thoughts? I know, right? How can we try it? What were you thinking? You want to help him out?
2.5?
2.5 is interesting. 2.5 is essentially 2 1/2. If we add up 2.5 and 2.5, 2 1/2, 2 1/2, we get 5. But we still have that 1/2. I think there might be a more straightforward way, because you could do it that way if we bring in that extra 1/2. But how else could we split up 5 1/2 more friendly? What do you think? She's got it. Go for it.
5 times 1.
5 times 1, that gets us to 5, right? Think about what 5 1/2 is really equal to, right? It's just 2 numbers that we add together. So how would you split that?
2 plus 3.
Go ahead.
2 plus 3.
Well, that's just 5. We still have that 1/2, right? Yes?
I think it would be the 5 and then the 1/2.
Yeah, because 5 1/2 is the same thing as 5 plus 1/2, right? So let's do that. 5 and 1/2. Now, we said one of the benefits of the area model is that we can choose what to multiply together. What do you want to start off? What could we multiply first? Go for it.
10 times 5.
10 times 5 equals?
50.
Great. Let's do another one. Yes, sir.
1 times 5.
1 times 5. Going for that easy money here. What do we got? 1 times 5 equals?
5.
Great. Okay. What can we multiply next?
10 times 1/2.
Oh, 10 times 1/2. What do you think 10 times 1/2 is? Or what is 1/2 of 10?
5 10.
What about 1 times 1/2? 1/2, because anything times 1 is itself. 50 plus 5 plus 5 is? Well, 5 plus 5, that's 10. Plus 50 is 60. And we have one more piece to add. 1/2. Ladies and gentlemen, 5th grade Evergreen Elementary just did 5 1/2 times 11. Give yourself a round of applause, ladies and gentlemen. That area model is always going to get you far.